So you use tools like ChatGPT all the time, right? But have you ever stopped to think about how it actually understands what you're saying? Well, it's definitely not magic. Today, we're going to pull back the curtain and take a tour of the factory where AI actually builds meaning.
I mean, it really does feel like sorcery sometimes, doesn't it? You ask it something complex, and boom, a pretty solid answer comes back. But behind that screen, it's a super fascinating step-by-step process. And to show us around, we've arranged for a couple of special guides. Think of them as AI avatars of two people who know a thing or two about this stuff. OpenAI's Sam Altman and Tesla's Elon Musk. They're going to help us see how language gets taken apart and put back together. All right, let's head inside. First up, our AI, Sam Altman, is here to welcome us to the factory floor. He says, "Hey, welcome. Think of this whole place as an assembly line, but for ideas. We're going to follow one sentence from start to finish, from just raw words to a fully understood concept. You ready? Let's go." Okay, so every factory needs raw materials, and in our factory, that material is text. For this tour, we're going to watch this simple sentence go through the whole system. The robot ate the apple. This little phrase is about to get completely deconstructed and then rebuilt from the ground up. Now, here to walk us through the first critical steps on the prep floor is our AI, Elon Musk. He's telling us, right, before you get to the really powerful stuff, the input has to be prepped. You can't just throw messy, raw sentences into the machine. That's just not efficient. First thing you got to do is break it all down.
And that first prep step is something called tokenization. Our AI Sam explains. Exactly. Just imagine you're breaking a sentence into individual Lego bricks. The robot ate the apple. Each one becomes its own little piece, its own token. It's really the only way the machine can even start to work with them.
So once you have these little word bricks, they have to be translated into a language the computer actually understands, which is, math. AI Elon jumps in here. Yep, every single one of those tokens gets turned into a long list of numbers. We call it a vector. You can think of this vector as a set of coordinates on a gigantic multi-dimensional map of meaning. On this map, a word like apple would be close to pear or fruit, and king would be close to queen. It's all about where words sit in relation to each other.
But wait, the meaning of a sentence isn't just the words, it's the order they're in. So how does the AI keep track of that? Our AI Sam says this is a huge deal. Oh, this part is absolutely critical. We add another layer of numbers to each word's vector that basically acts like a tag, telling the model where it was in the original sentence. It's how the model knows the massive difference between dog bites man and man bites dog. So let's do a quick recap of what happens on the prep floor. First, we tokenize, chopping the sentence into words. Second, we embed, turning those words into numbers or coordinates. And third, we encode their position so the order isn't lost. Now our sentence is all prepped and ready for the main event. We are now entering the absolute heart of the factory. This is the place where the model stops just looking at individual words and starts actually understanding the relationships between them. This is where the real thinking starts to happen. Our AI Elon poses the big question. Okay, so you've got this list of numbers that represent words in an order. But so what? How does the system figure out that in the robot ate the apple, the robot is the one doing the eating? How does it build real context out of just a flat list of data? And here's the answer from our AI Sam. The breakthrough that made all this possible is a mechanism we call multi-head attention. The simple way to think about it is that it lets the model look at the sentence from many different angles all at once. One attention head might be figuring out the who did what part. Another might be tracking what a pronoun like it refers to. By combining all these different views, it builds this really rich, layered picture of what the sentence actually means. Let's look at a slightly more complex example to see it in action. If you have the sentence, "The robot ate the apple because it was ripe," the attention mechanism is what draws the lines connecting the words. It learns that it almost certainly refers back to the apple, it connects robot to the action ate, and it understands that ripe is describing the apple. It's literally paying attention to how every single word relates to every other word in the sentence. It's pretty incredible. So once all those connections are made, the information moves on to the next stage, the deep learning room. Our AI Sam explains,
Okay, so now that the model has a good grasp on the context, it sends all that information through a bunch of identical processing layers to, well, basically to think about it all on a much deeper level. This next part is called the feed-forward network. You can think of this as the factory strategy room. After the attention engine has figured out who's connected to what, this is where the model considers all those connections and starts to make inferences to figure out things that weren't even explicitly said in the text. Our AI Elon chimes in with a crucial point. Look, in a system this complicated, the signals can get really messy. They can get distorted or even just fade away as they go from layer to layer. So layer norm and residuals are basically your quality control. They act like a combination of noise-canceling headphones and a signal booster, making sure the important information from the beginning never gets lost and the whole factory runs smoothly. And just like that, we've made it to the end of the assembly line. Our sentence has been chopped up, turned into numbers, had its context mapped out, and been deeply processed. Now it's finally time to create the finished product, language that we can actually read. According to AI Sam, this last step is called decoding. You can think of decoding as pretty much the reverse of what we did at the start with embedding. The model takes its final, really complex numerical understanding of the topic and starts translating it back into words. This is the moment where it predicts the most likely next word to answer your question, or to finish your thought, or even to translate your sentence into another language. And to sum it all up, here's our AI Elon one last time. So you see, it really isn't magic. It's just a very, very elegant pipeline of logic, context, and pure probability. The only magic, if you want to call it that, is the mind-boggling scale and speed that it all happens at. So there you have it. We've gone inside the factory and we've demystified the how. We've seen the assembly line that makes these incredible language models work. But that leaves us with a much, much bigger question. It's not really a question of engineering anymore. It's one of philosophy. Now that we understand how it thinks, what should we have it think about? And that's the conversation that really matters next.